Today, we're jumping into a scientific detective story, one that could totally flip the script on everything we thought we knew about Alzheimer's disease.
For years and years, science has had a prime suspect, a #1 bad guy in the Alzheimer's story. But what if? What if that villain was never the bad guy at all? All right, let's meet our so-called villain. Its name is Amyloid-Beta. And for decades, this single protein has taken pretty much all the blame for the heartbreaking damage that Alzheimer's does to the human brain. Now, the main theory, the one that's guided literally billions of dollars in research, is called the amyloid cascade hypothesis. The idea seems super simple. Amyloid beta is basically just toxic gunk. It builds up in the brain, it forms these sticky clumps called plaques, and those plaques just kill our brain cells. Seemed pretty open and shut. So you can see the logic, right? If the problem is just a bunch of toxic waste, well, the solution must be to clean it up. So the entire medical community went all in on this, creating what were basically plaque-busting drugs to just blast this stuff out of the brain. A really great goal, but the results were confusing.
Because this is where our detective story gets a major twist. The cures, they just weren't curing anyone. The evidence that was coming back from all these clinical trials, it just wasn't adding up. And that led to this one huge, nagging question that haunted the entire field. I mean, the drugs were technically working, they were getting rid of the plaques, but the patients themselves, their memories, their ability to think, none of it was getting better. So if we were taking out the bad guy, why weren't we getting a happy ending? So the case against amyloid beta just started to completely fall apart. We saw trial after trial come back with the same result. Getting rid of the plaques did not bring back brain function. It became painfully obvious that we were missing something. A huge piece of the puzzle was just gone.
And that failure, that missing piece, forced a totally new way of thinking. It's a radical new hypothesis you can think of as the volume nog theory. And it suggests amyloid beta isn't a villain at all. It's just misunderstood.
Okay, look at this, because this right here is the whole story pivot. The old view saw amyloid beta as toxic waste that you just had to get rid of. End of story. But this new view, it sees it as a vital regulator, like a traffic controller for our brain cells that needs to be carefully attuned, not destroyed. And this is just the perfect analogy. Think of amyloid beta as the volume knob for the communication happening between your brain cells. With Alzheimer's, that knob gets cranked way too high, causing all sorts of static and damage. But the old drugs, they were basically just ripping the knob off completely, turning the volume down to 0, and stopping the music of memory altogether. And just so we're clear, that music we're talking about, it's a real biological thing. It's called synaptic plasticity. It is the physical process of connections between your neurons getting stronger or weaker. This is literally the nuts and bolts of how you learn and remember, well, anything. So you have this incredible new theory. How in the world do you go about proving it? Well, you have to design an experiment that can actually listen in on the brain at the exact moment it tries to form a memory.
So here's the game plan. You take mice that are engineered to get an Alzheimer's-like condition. Then you very precisely dial their amyloid beta levels up or down, just like turning that volume knob. And while you're doing that, you're recording the electrical chatter between their neurons and testing their memory in things like mazes.
So what exactly are they listening for? They're on the hunt for a very specific electrical signature. It's called long-term potentiation, or LTP for short. And you can think of LTP as the literal spark that flies the moment a new memory is physically forged in the brain. And this is what the science predicts. When amyloid beta is too high, like in Alzheimer's, that memory spark is weak, it's noisy, and the mouse is terrible at the maze. When it's too low, which is what the old drugs were doing, the spark is just silent. The music's off. But if they can tune it to that perfect Goldilocks zone, the spark is strong and clear, and the mouse aces the memory test. So what does this all mean for the future? Well, it is a massive shift. We're moving away from thinking of this as a simple cleanup job to seeing it as a really sophisticated tune-up. Let's just look at this one more time. The old way of thinking was basically waste management, clear out the gunk to stop more damage. The new way is all about metabolic regulation. It's about fine-tuning the brain's chemistry. And the goal is incredible. It's not just to stop the disease, but to maybe, just maybe, actually restore brain function. And this is the real hopeful heart of all this new research. It suggests that memory loss might not have to be a one-way street, that with the right kind of chemical tuning, we might actually be able to turn the lights back on. This incredible insight and the amazing research behind it is brought to you by the Vario One platform. If you believe in protecting not just lives, but minds, hit that like button and subscribe for more breakthroughs. Dive deeper into the research and explore more on the Vario One platform. See you there.
It really leaves you with a final thought, doesn't it? What other scientific villains out there might just be heroes that we haven't taken the time to understand yet?